Evaluating information and misinformation. Here we're going to be talking about the major tools, processes, and issues for evaluating valid and truthful information. So there are essentially two major processes for acquiring valid information, and that is the empirical observation, and sometimes also called induction. And these are things like seeing or hearing or tasting, smelling, and touching. So the five senses. So the senses are important and necessary, but they're not sufficient, right? There's a component of it. And we call that empirical observation or induction or inductive inference. Although inductive inference goes a little bit more specifically into something else, but also logical inference. And we also call this deduction. So this is the kind of if-then reasoning or mathematical reasoning or analysis, mathematical analysis, and things like that. So these are really the two major ways that information, any kind of information, and certainly any kind of valid information can be assessed. So there's the major cognitive processes. I even include this term next time. So let's have a simple example here. Who stole the bananas from the table last night? Well, we saw Andy do it. I saw him take the banana and start eating it. So he definitely did it because I saw it with my own eyes. It was so clear. You can call this a kind of empirical observation. Or maybe we didn't see, but we saw him sleeping, and Andy only sleeps after eating bananas. Therefore, he likely was the one who took the banana because the banana disappeared and he was sleeping, and he only sleeps after he eats bananas. So therefore, by our logical inference is that he did steal the banana. Now, there are actually two major versions of each of these. So there's a weak and a strong. So the weak one is really just the direct observation of one case or somebody's account. And that's why we call this anecdotal evidence. And that kind of anecdotal evidence has a little bit of it's a shortcoming. It's not like a good thing. Anecdotal evidence can be good, but it's anecdotal. It's weak. It's just what somebody saw or heard or felt. Therefore, it's not very reliable. But in some cases, it's good and it can be used in the courtroom, but it's also, this can just be hearsay. And people say crazy things, some people are crazy. So who knows if they're saying what's true is true or not. But there's also a strong empirical observation, which is direct observation in an experimental or careful study where biases and confounding factors are controlled for. And this is what usually people talk about empirical data or empirical observations, even the plural, because there are many. And this is much more reliable because there are many people there looking. There's experimental, it's careful, there's all kinds of biases are controlled for. People think about the other factors that could have impacted a situation and so on. And then we also have both weak and strong for logical inference as well. So a weak logical inference is a kind of probabilistic inference, such as the monkey often eats the banana from the table. So who stole the bananas last night? Well, the banana was probably eaten by the monkey. Now, in some cases, this could be strong, and you probably need that extension and specificity and further explanation to see if this is a reasonable logical inference, even though it's probabilistic. But the way it's stated here, it's almost kind of like probability could be 20%, could be 30%, could be 70%. I mean, just too varied. So this is kind of like a weak inference. Also, we can have strong logical inference, which is a very strict logical deduction, such as Plato is a man will die, thus Plato will die. This is usually what people think when they think about deduction, deductive reasoning, or deductive inference. And also mathematical reasoning and analysis is like this too. It's kind of, 1 + 1 = 2, and that's it. There's nothing, it's not 3, it's not 2.5, it's not 2.135. 1 + 1 = 2, and that's it. So both of them can be useful. Weak doesn't mean useless. Weak just means not as strong as the strong. Same thing here as well. Weak can be good, maybe there's only one person there who saw it, so it could be important to have that person's observation. So let's test here how the empirical and the logical inferences apply to specific kind of questions. Some we had before. So how old is Carol Anderson? Well, I found on Wikipedia she's 62 years of age. So it's kind of, in a way, it's hearsay. I didn't check it myself, but I saw it on a relatively reasonable site. And then we can actually have a logical inference associated with this observation. Since Wikipedia is generally reliable in reporting people's age, we can logically infer that she is probably 62 years of age, because that's what they write. So there can always be, and there usually always is, a logical, analytical, this is also called analytical, let's say, inference, but the other one can be analytical too, so I'm not sure about that. There is associated with finding answers to questions. How tall am I? How do I get answer to that? How tall are you? How do you know? Well, you can just measure. Just take a tape measure, put it from the head to toe and see what the number is. And whatever number you see, that's probably how tall you are. So there's not much, this is not necessary, right? It's just the empirical observation. Was the 2020 US presidential election stolen? How are we going to know this one? Do I have some answers? Let's say, oh yeah, empirical. Jane saw the presidential election being stolen with her own eyes. This is the empirical evidence. Well, we can probably see some problems here. These are abstract, and we didn't explore this, but presidential election is a general, abstract, complex process that involves millions of people. How could she see the millions of people? It's not possible to see an election. An election is abstract and general process. My own one voting is concrete, specific. I vote in a particular place and so on. But this is a general and abstract. So it's not possible for anybody to just look at it, listen to it. So empirical here is not going to work, but there could be other empirical, right? Examining the voting records and so on of thousands of people. So you can observe the data from that. So I just wanted to play around some ideas here. The logical inference could be most Democrats are bad and would steal an election because they're bad. Therefore, they probably stole it. Once again, I'm not sure if you can tell, but this is a really bad logical inference. And that's because the premises themselves are weak. Most Democrats are bad. Bad according to who? Who determined bad? Is this controversial? Is that widely accepted? Also, would steal an election. Maybe they are bad in some ways, but that doesn't necessarily mean they would steal an election. They can be bad in many ways, but steal an election, therefore, it doesn't mean they would steal an election. So the conclusion just doesn't follow from the premises. Therefore, this example here is not a logical inference. This example is not a good empirical observation, but we're probably going to need both empirical and logical ways to get to the answer to these kinds of questions. What will be the impact of climate change on coastal communities? Once again, we're going to need an empirical sort of information, empirical source of data, and we're also going to need logical inferences, mathematical models. So we're going to need to observe several communities over time under conditions of different climates. We're going to need to observe related factors such as precipitation and elevation to see how different communities will be impacted. We're also going to need to analyze data with statistical models, proper statistical models in probabilities that can lead us to a good answer. So we're going to need both empirical and logical processes, cognitive processes to get to this kind of answer. I'm going to take a pause here. I'm going to continue with information evaluation actions and criteria.